In this video, we will be looking at the 5-number summary, boxplot, and outliers. The 5-number summary gives us a way to describe a distribution using only 5 numbers. These 5 numbers include the minimum, first quartile, median, third quartile, and the maximum. So, if we took a sample and measure some random quantitative variable, we could order these values from smallest to largest and use the 5-number summary to describe the distribution. The minimum is the smallest value in the dataset, and the maximum is the largest value in the dataset. The median is the middle data value. It is a point at which 50% of the data values are below the median, and 50% of the data values are larger than the median. Now the median of the bottom half is called the first quartile. It is a position where 25% of the data values are below it, and 75% of the data values are larger than it. The first quartile is essentially the median of the median. The same thing can be said for the third quartile. The median of the top half gives us the third quartile, and it is the position where 75% of the data values are below it, and 25% of the data values are larger than it. The 5-number summary also gives us a way to divide the data into 4 equal quarters. So let's determine the 5-number summary for the following data set. We will start with the median. To find the median, you can look for it visually, and you should find that the median is equal to 33. You can also use the formula to find the position of the median, and we find that it is in the 8th positions, which is equal to 33. Now to find the first quartile, we can use the same formula to find the position of the Q1, except this time n refers to the number of the data value below the median. There are 7 data points below the median, so n is equal to 7. And we find that the first quartile is in the 4th position. So we count to the 4th position and we see that Q1 is equal to 25. To find the third quartile, we will do the same sort of the thing, except n refers to the number of the data values that are above of the median. There will always be the symmetry, so you should find that Q3 is also in a position 4. So we count 4 positions above the median, and we find that Q3 is equal to 36. Now the minimum is the smallest number, and the maximum is the largest number. So as a result, this is our 5-number summary. We can then take these 5 numbers and make something called boxplot. A boxplot gives us a visual representation of the 5-number summary, and it looks something like this. Each vertical line on the boxplot represents a number from the 5-number summary. The horizontal line that extends out from the box are called whiskers, and the actual box itself is called the interquartile range. The interquartile range refers to the middle 50% of an ordered data set, and it is equal to the third quartile minus the first quartile. We can also have something called a modified boxplot. It is like a regular boxplot except accounts for outliers. Sometimes outliers in the dataset aren't that obvious. However, we can mathematically check if a dataset has an outlier in it. We say that a data value is considered to be an outlier if the data value is less than Q1 minus 1.5 times the IQR, or if the data value is greater than Q3 plus 1.5 times IQR. So if you remember the following dataset, we had calculated the 5-number summary to be 10, 25, 33, 36, and 59. To check for outliers, we first need to calculate the interquartile range. We found that Q3 is equal to 36, and we found that the Q1 is equal to 25. When we simplify this, we get the answer of 11. Now we say that a data value is an outlier if it is less than Q1 minus 1.5 times the interquartile range, or if it's greater than Q3 plus 1.5 times interquartile range. At this point, we can start substituting values. Q1 is 25, Q3 is 36, and the interquartile range is equal to 11. And so we say that a data value is considered to be an outlier if it's less than 8.5 or if it's greater than 52.5. If we look at our dataset, we see that no values are less than 8.5. However, we do have a value that is greater than 52.5. Therefore, we see that 59 is an outlier. And so, when we make a modified box plot, we write the outlier as a dot, and the whisker will only extend to the new maximum. In this case, it is 15. So to quickly recap, a regular box plot is drawn using the 5-number summary. And modified box plot also uses the 5-number summary, but it counts for outliers. And if there are outliers, a whisker or both whiskers will extend only to the new minimum or maximum. Similar to back-to-back stem plots, we can have side-by-side box plots. By having them side by side, we can make easy mathematical and visual comparisons between two sets of data.